So hello students, welcome to IMS GATE Academy. I am Amit Goyal and today we will be discussing about theory of computation's topic, which is known as deterministic finite state automata, right? So I hope all of you attended the previous session in which we discussed the brief introduction of the subject, that what is theory of computation and what are its application, where it is used. That is basically we discussed, and we discussed the basic terminology, like what are the basic terminologies. For example, symbols are there, then we have the alphabets in that, then we have the strings in that, then we also have the language, right? So we discussed the basic terminology in the last session, and then we also discussed about the powers of sigma. What is sigma raised to power 0, sigma raised to power 1, sigma raised to power 2, sigma raised to power 3, and so on up to sigma star, right? So that's what we all discussed, and we also discussed that how an automata helps us in accepting a language, and it also helps us in accepting a string or rejecting a string, right? So this is what we discussed in the last session, and in this session we will be specifically be discussing the topic of deterministic finite state automata, that is DFAs, right? So I hope so if there are any doubts from the previous session, you can type in the chat box and ask me the doubts, and then we'll briefly start with DFAs. Are there any doubts? If there are students, can you please type in the chat box that about your presence, and then also let me know if there are doubts. Yeah. Okay. So, okay. So now as planned, as I discussed, so I think I hope since I did not receive any doubt, I am assuming that there are no doubts, and if there are, you can ask in between also, there is no issue, right? So now let us specifically talk about DFAs today and try to understand this concept in a bit detailed form, right? So we'll directly do this and understand this concept with the help of a question, and then let us try to draw the DFA and then understand what are the basic terminologies involved in the construction of DFAs, right? So let's see this question. I'll give you some 2 minutes to design this, and then we'll discuss the solution as well as I'll explain the basic concept. So this is the first DFA. You can take some time to draw it, and then based on that we will see. So you have to tell me the number of states in this, right? So let me set the timer. So you have to report to me the number of states in this DFA, as well as the number of final states. Right? Yeah. So just in the next 2 minutes, you try to solve this question. If there are, then we'll discuss the detailed solution and we'll discuss the terminology also. Yeah, answers, guys. So it's a very, very simple and straightforward question. You should be able to solve it. Okay, I think the time is up. I will give another last 1 minute to solve this, and after that I'll solve it, right? So let me briefly explain the question also. It says that construct a minimal DFA which accepts set of all strings over sigma equals to a comma b. So your alphabet is sigma a comma b, and such that the string starts with an a. So the language which is defined is strings which are starting within a, right? So now you should be able to make the DFA. Okay, yeah. So yeah, great. Yeah. So Ravi is correct. He says 3 states, and the number of final states he says as 1 final state. Okay, great. Okay, so let's try to draw the DFA and understand the various terminologies involved in the DFAs. How and basically we can draw this DFA, right? So let's see. So what is being said is, so first of all, the first step whenever you are trying to make a DFA, you should always write down the language, that what is the language. So for example, if you see in this case, what is being said is, the strings are starting with an A, and your sigma is already defined to be A comma B. So the smallest string which starts with an A is basically single A, right? So single A starts with an A, then AB also starts with an A, then maybe AA also starts with an A. These are the 2 length strings. Then we also know the 3 length strings which are starting with an A. For example, AAB, ABA, ABB, and which one is left? AAA, right? And so on. So this is basically an infinite language. So what is very clear from here is, this is an infinite language, right? And if the language is infinite, this is how we will just briefly discuss how we have to construct this DFA. What are the various steps involved? We'll see that. So first of all, we know that A is the smallest string that is acceptable in the language. So we will construct the DFA for, A first, right? So first of all, when we get an A, we go to the final state, right? So as soon as we get an A, we go to the final state. That means the string is starting with an A, and after that, whatever comes, we are going to accept that, right? So therefore, on A we'll have a loop. On A we'll have a loop on the second state. So basically, on A comma B we'll have a loop. So this is Q1, and say this is Q2, right? So let me draw it a bit neater so that you can see the number of the states also. So here we have Q0, and here we have Q1, which is the final state. And when we get an A, the string is accepted, right? Now after that, whatever comes, whether it is an A, whether it is a B, whatever it is, it will be accepted, right? So I will put a loop on A comma B, right? Now what if the string starts with a B? Then in that case, the string is definitely going to be rejected. I will make a new state, say Q2. I'll make a new state, say Q2, and if we reach this state, we should not reach the final state in any case, right? So that means that Q2, your Q2 is basically a dead state. What is a dead state? Does anybody knows? What do you think is a dead state? What do you think, guys? What is a dead state? What is the meaning of a dead state? What do you guys think? Any answers? Okay, so basically dead state is something from where you can never reach the final state, and once you reach that state, you will be stuck in that state, right? So from where there is no path to the final state, that is basically known as the dead state. Okay, so Ravi says once it reaches, we cannot coming. So we cannot come back, we cannot, so from where there is no path to the final state, right? So dead state, for example, there may be a set of dead states which may be looping among themselves. So we cannot say that we cannot come out of it. You can come out of it, but you go to some set of states which are again, and none of them is a final state, right? Are you getting this point? Yeah. So you can go among the dead states, but you will never be able to reach the final state. That is basically a dead state, right? So it is not important that you always remain and stuck at the dead state. It may be a set of states in which you can revolve among them, and then you cannot never reach the final state, right? So the basic idea is from where there is no path to the final state, right? So okay, so he says so through which we cannot control the through which we can control the unacceptable strings of DFA. Am I right? Perfectly fine. So because since so you are 100% correct, Ravi. So why it is so? Because when I am saying from where there is no path to the final state, that means that that string will not be accepted, right? Are you getting this point? Yeah. So when I am saying there is no path to the final state, it is as good as saying that it is going to represent the unacceptable strings of the DFA. You are 100% correct, right? So so this is the minimal DFA which is going to accept set of all strings over sigma equals to a comma b such that the strings are starting with an a, right? So now when we are constructing DFAs, we should briefly understand the terminologies. So again, just to let you know, we want the string starting with an a. So as soon as the string starts with an a, I reach the final state and I have put a loop over there, just to tell that whatever comes after this, I don't care. I will be in the final state. And when it starts with b, I will reach to a dead state, and after that whatever comes, I don't care. I will be in the dead state, right? So that is how I have constructed the basic DFA. Now let us understand the terminologies. What is the quintuple for a DFA? We'll understand that, but let us first of all understand what are all the contents of this DFA. So what is there in the DFA in the diagram, right? So for example, when we see a DFA, we represent the states. The states are being represented with, so the states are represented with circles. So that is the first thing. Now once we have the states, the final state is represented by a double circle. So this is basically your final state. So you initially have states, you have that are represented by circles, and then you have a final state which is represented by a double circle, right? Now how do you represent the initial state? The initial state should have an incoming arrow without any alphabet on it. So basically the initial state will be represented like this. Just not to confuse you guys, I will just not put any other arrow because arrow is there in the diagrams also. So this is your initial state, right? And then you have arrows. What does the arrows means? Arrows are basically transitions which take you from one state to another state. Right? So transitions which take you from one state to another state on accepting an input alphabet. Yeah. So Ravi says, yes. So the incoming arrow is to the initial state, right? And arrow represents the transactions between, not the transactions, but the transitions, Ravi, right? So transitions between the states, and then transitions which take you from one state to another state after accepting an input. Right? So these are the transitions which will take you from one state to another state on accepting an input, right? So these are the basic building blocks. Like that is what we see in the DFAs when we show them in a pictorial way, right? So for example, you have the states here, then you have the transitions there, and then you also have input alphabet is also there that will be written on the transition. So in the transitions definition, I also said transitions which take you from one state to another state on accepting an input. right? So you will take one input and on that you will go from one state to another state. So every transition you will find that there are certain input alphabets which are written. So this basically Q1 on A and B, both it is going to Q1. It is as good as saying that there are two transitions involved here. It is not just one transition, right? So ideally, if you see, if you draw each and every transition differently, how this transition diagram, how this DFA will look like, let me draw. If I draw them differently, so for example, on Q0, on A I am going to Q1, which is a final state. Q1 on A also is going to Q1 and Q1 on B also is also going to Q1, right? Although these are two different transitions, I have put them into one so as to make the DFA concise, right? Similarly, Q0 on B was going to Q2 and Q2 was a dead state. So on A and both A and B, it was going to Q2 only. So these are two different transitions. So overall, if we see this DFA, we have some 6 transitions, right? And what was the question that I asked? The number of states. The number of states are basically 3. And the number of final states is basically only 1. Right? So this is basically a basic introduction to DFAs. Now we'll draw a lot many DFAs to understand exactly that and to get a hand on the DFA so that any DFA that comes in the exam, we are able to solve that, right? So, so let's see the basic terminology also. Like for example, a DFA is represented by a quintuple. So by quintuple means that is 5 elements. Quin means 5. So it has 5 elements which are known as Q, sigma, delta, Q0 and F. So let us see the previous case that we had and let us see what is Q, what is capital Q, what is sigma, what is Q0, what is delta, what is F in this case, right? So let us try to understand it. So Q is basically the set of states. It has to be a finite set of states. This is basically a finite set of states, right? I think I discussed in the last class this in very detailed form that the representation, basically automata is a representation. Yes, exactly, right. So what I'm trying to say is, what is important to understand over here is given, so what is the main purpose of DFA? DFA is to accept, is to tell you at the runtime that whether you are going to accept a string or you are going to reject a string, right? And if the language is infinite, I cannot store all the strings in the language and tell you at a runtime that here whether the string belongs to the language or not. So that is why we brought DFAs into picture. DFAs came into existence and they were to tell you that given a string and an infinite language, whether the string belongs to the language or not, this question will be answered by the DFA. So this DFA representation, this representation of the DFA has to be finite. If this representation is infinite, then it becomes a chicken egg problem. So DFAs were to solve a problem which was infinite, right? The problem of storing the infinite strings in the language, we wanted to solve that problem, and somehow if again the DFAs become an infinite thing, so if the representation of the DFA itself becomes infinite, that will be useless. So it is very, very important to understand this subtle point that the DFAs are going to be, the representation of the DFA is going to be finite. If this representation itself turns out to be infinite, how will we store this representation in order to check at runtime that whether the given string belongs to the language or not, right? Are you getting this point? That this representation of DFAs has to be a finite representation. And if I am saying that these are the 5 tuples, this is basically the 5 tuple of the DFA, that is, this is basically the quintuple of DFA. All the elements inside this DFA have to be finite. Otherwise, there is no point of discussing the topic of DFAs, right? So basically, Q is basically the finite set of states. Then we basically have sigma. So what is sigma? Sigma is basically your input alphabet. This we discussed in the last class also. So in this case, the example that we drew, what was Q? Q was basically Q0, Q1 as well as Q2. All of them were there, Now, what is your sigma in this case? What is your input alphabet in this case? Basically A and B. How do we know that? It was already given into the question, which was telling you that construct a minimal DFA which accepts set of all strings over sigma equals to A comma B such that the string starts with an A. So basically your sigma is already given to be as A comma B. Now what is this delta? We'll discuss after a while. Let us talk about Q naught first. This is your initial state. So your initial state will always be single. It will not be the case that you will have many initial states. Initial state will always be a single initial state. You will not have multiple initial states. So this is a single Q naught, so this is not even a set. Because if you have multiple initial states, how would you know where to start? Right? So therefore Q naught will always be a single thing. And what is F? F is basically the set of final states. So in this case, we are getting only one final state, which was Q1, but there might be, yeah, so that's what I said, Ravi. So initial state will always be 1. That is why I said that this is not even a set. This is just one state. If you have multiple initial states, you will not have any idea where to start with. So therefore, initial state is always going to be 1. Yeah. So now when we say F, F is the set of final states. Right. So basically, the number of final states can be more than 1 also, but it is always known that this F will always be a subset of Q. You cannot have more final states than the total number of states, right? So F will always be a subset of Q. There can be a case where all the states are final. That is also possible. Right? It can be, so you can have it. You're right, Ravi, that the number of states can also be more than 1, and they can even be equal to the set of original states also. All the states can be final in that also. In that case, yes, if all the states are final, in that case the language is basically sigma star. Whatever you are giving, you are accepting that in case of DFAs, right? Now what is delta? Delta is basically the transition. It is going to take you from Q cross sigma to Q. On every state, exactly. So on every state, given an input alphabet, on every input alphabet, you are going to go to some state. So it is basically a mapping from Q cross sigma to Q, right? So in every combination of Q cross sigma, you will go to some state, right? So that, for example, on Q naught on A, Q naught on A, Q naught on B, Q1 on A, Q1 on B, Q2 on A, Q2 on B. So we should know the answers for all of them. So Q naught on A was going to Q2, Q1, Q naught on B was going to Q2, Q1 on A was going to Q1 itself, Q1 itself, Q2 itself, Q2 itself. So this is basically, this entire thing that I have written over here is basically your transition function. So on every combination of input as well as the state, you will go to some state. So basically, this is basically Q cross sigma to Q. So whatever is possible, this is basically a cross product of Q and sigma. So whatever is possible. So you have in this case 3 states, 3C1, 2 input alphabets, 2C1. So you will have 6 combinations. That is Q naught A, Q naught B, Q1 A, Q1 B, Q2 A, Q2 B, right? So you will have some 6 combinations. On every 6 combination, you have to tell me where I am exactly going, right? And that is how the term deterministic comes into the picture. So that is how the term deterministic comes into the picture. That is why we call them deterministic. So on every combination of Q naught and input alphabet, I am going to tell you on what state I want to go. That is why we call them deterministic. and on every combination we are only going to go to one particular state. You cannot go to multiple states. So these are the two reasons why we call them deterministic. So let me reiterate this point. So deterministic means your transition function is deterministic. Your transition function is deterministic. Function is deterministic. So what does it mean? What does it mean when I say my transition function is deterministic? What does it mean? Exactly. It will respond to each input. That is one point, Ravi. And the other point is, on every combination of Q cross sigma, you are going to only and exactly one state only. You cannot go to multiple states. These are the two things which are making it as deterministic, right? So for one thing is, for every combination you have to tell, but and the second thing is, on every combination you have to go to only one state, right? So for every combination of Q and sigma, you have a transition and every transition takes you to one single state. You cannot go to multiple states. So every transition is going to take you to one single state. You cannot go to multiple states, right? So these are the two things which make the DFAs as deterministic. That is why the first word D comes into the picture, right? The transition function is going to be a deterministic transition function, right? And similarly, when I say finite state automata, so the number of states are going to be finite. So basically the number of states that we have is basically finite. That is why we have finite state, and automata is basically, since it's a machine, that is going to tell you that if takes so this is called a machine because it takes an input and tells you whether this belongs to the language or it does not belongs to the language. It tells you that whether the string that you have given to me is belonging to the language or it is not belonging to the language, and the automata that we have drawn is basically representing that string, that language, right? So that automata is basically representing the automata represents the language which you are suggesting, right? So for example, the automata which we drew earlier, that was basically telling you that, so the automata that we drew earlier, that was basically for accepting the strings which are starting with an A. So this is basically your language. So your language is the strings which are starting with an A. So this automata represents this language which says that the strings are going to start with an A. Now once we have this automata, now if you give any string to it, it is going to tell you that whether the string belongs to the language or it does not belongs to the language, right? Now how do we check that? That becomes an important question. So how do we know that whether the given string that you have given to me is basically belonging to the language or it does not belong to the language? What do you guys think? How do we get to know that whether the string that you have given to me is belonging to the language or it does not belongs to the language? What do you guys think? So you have drawn the automata. Now the question is, you have to tell me whether the given string belongs to the language or not. Now how would you tell that the given string belongs to the language or not? Any ideas? How do we suggest that the given string belongs to the language or not using an automata? So we drew this automata to tell whether the given string at the runtime belongs to the language or not. Now how do we check that? We have drawn the automata, this is the automata that we have drawn. Now how do I check from this automata that whether the string which I have given to it belongs to the language or it does not belong to the language? That is the question which I am asking. Is the question making sense to everyone? How do I check at runtime? Yeah. So how do I check this point? Yeah. 10 seconds to you to answer this, then I'll answer it. What do you think? How should we check? Exactly. You are 100% correct. If the string reaches to the final state, right, then we can say that if the string, so we should not say the string reaches to the final state, we should say the trace should reach the final state. String will not reach the final state. On every input will go to some state. That trace should reach the final state. Then we declare that the string belongs to the language, right? So what would we say? That the trace, I would say that the trace should reach the final state. The trace should reach the final state. That's it. And if the trace does not reach the final state, I will say that the string is rejected, right? So how do I check this? So let's say, for example, if I give it the string, so what is trace? Let us try to understand through an example. So for example, I give the string A, B. Initially, I will always start with Q naught because that is my initial state. Q naught, on getting an A, I go to the state Q1. Q1 on getting an A, I go to the state Q1. Now Q1 on getting a B, I go to the state Q1 again. Now once I have read this entire string, what we get is basically the trace. This is basically your trace. So this trace that you have got, say that this string is not accepted by the DFA, because this DFA was representing the strings which are starting with A. Therefore, if you gave it a string which is starting with B, it will reject that string. So this is basically the string acceptance condition. So what is the string acceptance condition? The trace should reach the final state. This is basically the condition. Is it making sense? Yeah. So now once we have the condition for string acceptance, now tell me what is the condition for language acceptance. That's a very important thing. What is the condition for language acceptance? Right? Now what is very important question here is, what is the condition for language acceptance, right? Just a second. Just a second, I think, yeah. Okay. Yeah. So now let us see what is the condition for language acceptance. Now we know when a string is accepted when it reaches the final state. When the trace should reach the final state. If the trace reaches the final state, we say that the string is accepted, and if the trace does not reach the final state, we say that the string is rejected. Now what is important to understand now is, what is the language acceptance condition? When do we say that the language is accepted? When do we say that the language is not accepted? So basically, what is the language acceptance condition, right? So for example, just to motivate this problem, let me try to make a DFA, another DFA for the given problem. The problem was the strings which are starting with an A. So can I make this DFA for the language which contains those strings W such that W starts with an A? Does this DFA represents this language or not? That is the question that I want to ask. So when I say my language is W, W starts with an A, can I say that this DFA represents this language? Is the question clear? We have already drawn the DFA for this language. Now tell me, does this DFA also represents this language or not? What do you guys think? What do you guys think? Does this DFA also represents the same language or not? That is my question. 10 seconds to you guys to answer this. Then I'll answer it. What do you guys think? Yeah. So again, let me reiterate the question. The question is whether this DFA represents this language or not. We have already drawn this DFA earlier also, and we have seen that there are 3 states and 1 final state and 1 dead state in this DFA. Now I am asking that whether this DFA represents this language or not. This is the question. You have to tell me yes or no. And definitely give me the reason for the same. If yes, then why yes. If no, then why no. L is a subset of this DFA. Okay, I get it. I get your point. What is this DFA representing? What is this DFA representing? This DFA represents sigma star. That is basically, it represents all the strings over sigma equals to A comma B. This is basically the universal language, right? Now, when I am saying that, yes, exactly. When I am saying, does it also represent strings starting with an A? Is this the DFA for strings starting with an A or not? That is basically the question. The answer is no. This DFA does not represent this language, because when I say a DFA accepts a language, what does that mean? When I say a DFA represents a language, what does that mean? It means that the strings in the language, all the strings in the language should be accepted and all the strings not in the language should be rejected. That is a very, very crucial point. You should put this point in your short note also. This is a very, very important concept, and many questions in the GATE exam, people do mistakes in the GATE exam just by not remembering these 2 statements. They just forget this statement, and that is why they make the DFAs wrong. So the language acceptance condition is this only, that all the strings in the language should be accepted and all the strings not in the language should be rejected. Now, what was the problem with the DFA which I drew? The problem is it accepts the strings starting with A, but it also accepts the strings which are starting with B. And not only this, it also accepts epsilon, which is neither starting with A nor starting with B, right? So it is accepting the strings which are not in the language. That is why this DFA does not represent the language which I wanted. So different terminologies are used. It is also said that this DFA accepts this language. It is also said this DFA represents this language. Both mean the same thing. What is important is all the strings in the language should be accepted and all the strings not in the language should be rejected. This is a very, very important and a subtle point which you should always remember, right? So now, coming back to how to start drawing the DFAs now, right? We have already drawn 1 DFA. I'll just give you some pointers which will help you in drawing the DFAs faster, and then in this session we'll draw some more DFAs to understand this concept in a better way, and we'll apply all these 5 pointers on every DFA which we are going to make now, right? So first of all, you should write the language. How does it help you? This will help you in identifying the strings which are to be accepted by the language, and it also helps you in identifying the strings which are not accepted by the language, right? Then always take care of epsilon. So why I'm saying so? Because this also is a major enemy for the students, which makes the questions wrong, due to which the students makes the questions wrong. Why? Because if epsilon is the part of your language, then your initial state has to be the final state, right? if epsilon belongs to the language, if epsilon belongs to the language, then your initial state will be final state. Will be final state. So this is very important to identify whether epsilon belongs to the language or not. So this is a very, very crucial point. Then draw the DFA for the smallest string in the language. So once you draw the DFA for the smallest string in the language, then you start expanding the DFA, complete the DFA. So when I say complete the DFA, what does this term mean? Complete the DFA, you, as I stated in the definition of the transition function, for every combination of Q cross sigma, you have to tell me the transition. So that is how you will complete your DFA, right? Now once your DFA is complete, then you should also check that every state should have a unique meaning. What does that mean? That means that every state is representing certain idea. So you have to check that. I'll show you from the example which we have already drawn, right? So every state should have a unique meaning, because otherwise if every state does not have a unique meaning, what will happen is you will be able to somehow minimize the DFA if every state does not have a unique meaning. You will be able to do the same task in lesser number of states, and the question is always that you have to draw the minimal DFA. So therefore, what is important is that you should always see that whether every state that you have drawn is having a unique meaning or not, right? Is it making sense? Yeah. So these are all the major 5 points which I wanted to discuss, which will help you in constructing the DFA, right? Once you have constructed your DFA, so basically once you apply these 5 steps, you will be able to come up with a DFA faster, right? And there are very high chances that the DFA that you are going to get is definitely going to be the correct one, right? So therefore, try to follow these points. When we are discussing the questions in the session, we will definitely apply these 5 points, right? So basically, if I show you this example which we draw. So when I said every state should have a unique meaning, so for example, the Q naught is representing the states, the strings, only the string epsilon, that is neither starting with A nor starting with B, right? This represents the string starting with B. And this represents the strings starting with A. So every state has to have a unique meaning. That is what I wanted to highlight. Is it making sense? Strings starting with A, strings starting with B, and strings neither starting with A nor starting with B, that is epsilon, right? So this is basically the brief idea that how you should make the DFAs. So first of all, write the language, and in the language you always check that whether we have epsilon or not. In case epsilon is there in the language, then it is confirmed. Then it is confirmed that your starting state will be your final state also. And then after that, you make the DFA for the smallest string in the language, then expand the DFA to complete all the transitions, right? You have to complete all the transitions. On every state, you have to tell me where you are going to go once you accept any input alphabet. For every combination of Q cross sigma, you have to tell me your transition, right? Now, once you have that, every state should also have a unique meaning. Once you have obtained the DFA, apply this step to be sure that the DFA which you have got is definitely the minimal one, right? So let us see another example. I'll give you some 2 minutes to solve this, and then we'll discuss the solution for the same. So you have to tell me always, as usual, the number of states. You have to tell me the number of states as well as the number of final states. Right, so let me find out the timer. Yeah, so some 2 minutes to you to solve this. Okay, the number of states are 4, then number of final states are how many? Okay, great, great, Ravi. Exactly. You do not require a dead state in this case. Very good. So, yeah, so let us try to draw this. I think it's good that you could do this within less than 1 minute. That's great. Why we do not need a dead state? Because that condition does not arrive. Let's try to draw the DFA, right? So first of all, construct a minimal DFA. Let us read the question again. Let construct a minimal DFA which accepts set of all strings over sigma equals to a comma b, such that the length of the string is greater than or equal to 3. Length of the string is greater than or equal to 3, right? And what is being asked is what are the number of states and what are the number of final states. That is what is being asked, right? So let us see. Let us try to draw this. So initially, first of all, let us try to understand what is the language. So the language is basically, does the language contains epsilon? No, because the string length has to be greater than or equal to 3. So for example, let us take equal to 3. That means AAA belongs to the language, ABA belongs to the language, AAB belongs to the language, ABB belongs to the language, and so on. And similarly, the 4-length strings and 5-length string belong to the language. So therefore, this is an infinite. Therefore, this is an infinite language, and epsilon does not belong to the language. The first 2 steps are done. Now I will draw the string. Now I will draw the DFA for the smallest string in the language. Let's take as AAA as one case, right? So let's take AAA as one case. So you will have an A. On another A, you reach one more state. Now once your length is 3, now you can start accepting. Once your length is 3, you start accepting. Yes, exactly. It does not accept the epsilon because epsilon has 0 length. We want length greater than equal to 3, right? Now, when I say number of states, number of final states are also known to us. L is also known, and number of states and final states are to be calculated. L is known to us, and I have drawn this DFA for the smallest string in the language, right? So now let us write down the transitions for, I have to write. So I have basically got 4 states, that is Q0, Q1, Q2 and Q3. I have basically got 4 states, that is Q0, Q1, Q2 and Q3. Now I have to write the transitions for every combination of Q cross sigma. So I have not told what happens to Q0 once we get a B. Now even if you get a B, your length has become 1. So you will go to again Q1. Even if you get a B over here, again you go to Q2. Even if you have got a B, again you go to Q3 because the length is increasing, right? Now what happens to Q3 when you get an A comma B, A or B? Again your length is again greater than or equal to 3. You again remain on the final state. So this is how you will make this DFA. So initially made the DFA for the smallest string in the language, that is basically your step 3. In step 4, you completed the DFA. Now let us see whether every state has a unique meaning or not. Yes, there is. This state represents strings of length 0. This state represents strings of length 0. This is length 1, this is length 2, and this is length 3. Right? So that is how we are, yeah, great, great. So now when it is clear, now it is very clear that every state is having a unique meaning. The DFA which you have got is minimal one, and you are also sure that your answer is going to be correct. So for example, the number of states over here will be 4, and the number of final states which I am going to get is basically 1, which is your Q3. Yeah. So can you tell me the number of transitions here? Number of transitions in this DFA? How many transitions are there in this DFA? How many transitions are there in this DFA? Can you guys tell me that number? How many transitions are existing in this DFA? How do you calculate that? Although you can count it, or you can simply tell me the number. Although you can count it, or you can apply the simple PNC concepts to get that number. No, 6 is incorrect. You have to tell me the number of transitions in this DFA. So that has to be a concrete number. How many transitions are there in this DFA? Yes. Yeah. So what should be that number? Yeah. How do we calculate that number? Okay, so let me answer it. So it's very straightforward. So these are two transitions. These are another two transitions. This is another two transitions. These are also two transitions. So we have 8 transitions over here, right? And I can even apply PNC concepts to get that. I have to write a transition for every combination of Q cross sigma. How many Q I have? 4. 4C1 into sigma. Sigma is basically 2. So 2C1. So that is also going to give me 8. Is the solution clear? Right? Yeah. So Q 4C1 into 2C1. I think this is not visible. Let me write it above. It is going to be 4C1 into 2C1. It's going to be 8. That is how you can calculate. Right? Okay. So let's move to the next one. So again, construct a minimal DFA which accepts set of all strings over sigma equals to AB such that the length of the string is equal to 3. Earlier it was greater than equals to 3. Now it is equal to 3. What should be the answer now? Is there any change, or does it remains the same? You have to tell me the number of states as well as the number of final states. Yeah. So you can do it in 4 states you are suggesting. So yes, you will require one more state, right? So how many states in total? Final state remains only 1, that is correct. But how many total states are required? Exactly. So you will require 5 states in this case. So let us again draw this DFA again. So let us, now this length of the string has been declared equal to 3. So follow the steps. The first step is epsilon. Does epsilon belongs to the language or not? No, it does not belong. It has to be equal to 3. So the only string which I know is, first string is AAA, AAB, ABA, ABB, BAA, BAB, BBA, BBB. So this is the only language that I have. It is a finite language. And if the language is finite, I am damn sure we will be able to make DFAs. For finite languages, definitely the DFA will exist. For infinite language, we have to check whether we are able to make the DFA or not, right? So let's see. We already know the language is this. Now epsilon does not belong to the language, so the initial state is not going to be the final state. I will draw the DFA for the smallest string in the language, which is AAA. I will get this. Now once I have this DFA, now I will try to complete this DFA. How will you complete? You will have basically on B also you will increase the length. On B also again you increase the length. On B also you are increasing the length. Again this is the final state. Why? Because length is 3. Now on this state, if you have another length, for example, you have already got the length of 3, this state was representing length 0, 1, 2 and 3. Now if the length is 4, then you are going to a dead state. right? Yes, 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 we can definitely generalize it. We'll generalize it once we do one more question. We are definitely going to generalize this also. So now again over here, if you are going to get another A or another B, you are going to a dead state, because once your length is greater than 3, you are not going to reject all the strings which you are getting, right? So therefore, this way you can draw the DFA. And now if I ask you that what is the meaning of each state, this is representing length 0, again length 1, length 2, length 3, and this is greater than equals to 3. In the previous case also, this was also greater than equal to 3. If it is 4 also we are accepting, 5 also we are accepting, 6 also we are accepting, 7 also we are accepting. So this is greater than equal to 3 in this case. And now over here, this is greater than equals to 4, I should say. So if it is 4 and if it is greater than 4, then it is a problem. If it is 3, then we are accepting it, right? Is it making sense? Yes. So yes, we'll definitely generalize this. Just wait for a minute. We'll do one more question and then we'll try to generalize what exactly can be the generalization in this case, right? Is it okay? Yeah. So let's see, if I change the question to length of the string is equal to 3, we are saying here. If I say length of the string is less than or equal to 3, we have done the question on equal to 3, greater than equals to 3. Now the question is less than or equal to 3. What should we do now? What should we do now? Okay, number of states would be 5. Will you have a dead state in this case? Will you have a dead state in this case? Yes, exactly. So you will have one more dead state also in this case. Let us try to answer this. So what is being said is, construct a minimal DFA which accepts set of all strings over sigma equals to a comma b. Our sigma is same, a comma b, such that the length of the string is less than or equal to 3. That is being stated, right? So length is required to be less than or equal to 3. So now again, let us try to write down the language. Now do you understand that epsilon belongs to the language? Why is epsilon belonging to the language? Because length of the string has to be less than or equal to 3. When it is less than or equal to 3, length is 0 is allowed, length 1 is allowed, length 2 is allowed, length 3 is allowed. After that, lengths are not allowed, right? At most 3, exactly. So what will we write? Epsilon is allowed, A is allowed, B is allowed, AA is allowed, AB is allowed, BA is allowed, BB is allowed, and triple A is allowed, and so on, all the 3 length string, 8 of these strings, right? And this is basically a finite language length. So basically how many, can you tell me how many elements will be there in this language, total elements? Can you tell me the total count? How many elements exist in this language? What will be the total count? Yeah. Can you tell me the total count? How many strings will be there in this language? No. So the total number of strings in this entire language I am asking. What will be the total number of strings in this entire language? How many strings exist in this language which I have defined? How many strings will be there? Yes. So not 3 exactly. Sum of length 0, 1, 2 and 3. So what is that number? This is 1. No, Shilpa, it is incorrect. It's not 3. This is 2 of these. These are 4 of this and then plus 8. So what you get is 8 plus 4 plus 2. 8 plus 4 is 12. 2, 14 plus 1, 15 strings you are going to get. Yeah, is it correct? Right. So that's what. This is a finite language. So how do you draw? So length 0 is okay, length 1 is also okay, length 2 is also okay, length 3 is also okay, 1, 0, 1, 2, 3 is also okay, 4 is not okay, 4 is not okay, 0, 1, 2 and 3, 4 is not okay, right? 4 or greater than 4 are not okay. So this is basically again your dead state from where there is no path to the final state. And all these are final states. So this is the first example that we have done where there are more than one final states, and the number of final states can always be more than one. It is possible. It is possible to have more than one final states. It's not always more than one. It is possible to have more than one final states, right? So in this case, we have 4 final states. Out of the 5 states, we have 4 final states, right? Now, if I change the question, if I ask you what percentage, so before that, let me tell you one more thing here. So again, as I said, every state has a meaning. So this represents length 0, length 1, length 2, length 3 greater than equals to 4 length. So greater than equals to 4 length. Right? So this is how you can relate to the meaning of every state, right? Now let me ask you the question, what percentage? Slightly I am just trying to ask you more questions on the same scenario. So what percentage of states is final in the minimal DFA which accepts set of all strings over sigma equals to a comma b such that the length of the string is, what was that in the last case, less than or equal to 3, is at most 3, let's say it this way. So can you tell me what will be the answer here? What will be the answer here? Exactly. So again, just minor calculations. Again, first you have to draw the DFA and then you have to tell me the percentage. So it comes out to be 80%. Why? Because number of states that were final were 4, total states were 5. That becomes as 80%, right? So that is how. So how the questions can be asked? They can ask you the number of states, they can ask you the number of final states, they can ask you the number of transitions, then they can ask you so what is left? Sigma they will always tell you. Q, initial state, number of initial states, they are not going to ask. Why? Because there is always one initial state. So they are never going to ask you the number of initial states. There is always and always going to be one initial state, right? So, but then they can ask you the what percentage of states are final, right? What percentage of states is final, that is also can be asked. So 3 to 4 types of questions. Again, let me repeat it for you. One is number of states, other is number of final states, other is number of transitions, then what percentage of states are final. That's it. These are the 4 basic types of questions that can be asked, right? So let's try to solve. Now, can we generalize what we have done? So instead of saying greater than equals to 4, less than equals to 4, equal to 4, greater than equals to 3, less than equals to 3, or equals to 3. So that is when we say, when we are having some number. So can we generalize this on n? Can we generalize this on n? So how many states will be there in the DFA which represents set of all strings over sigma equals to a comma b such that the length of the string is equal to n. Length of the string is at most n. Length of the string is at least n. So what will be the generalizations in all the cases? Can you tell me the generalizations? So you tell me the answers for all three of them. Exactly. Very good. So the answer for this one is n plus 2, again n plus 2, and again n plus 1 here. Why? So again, you can understand it by the help of logic also. What you can do is, you can also take some n. So for example, we have taken the n in all our examples. In all our examples, we have taken the n as 3. Now for this case equal to n, we got 5 states. So that means n plus 2. Over here we also get 5 states, that is means n plus 2. And over here we got 4 states, so that means that is equals to n plus 1. I can say this by taking an example also and then generalize it over n, right? And moreover, if I want to think also, I can think directly. How I will think directly? When I say it is equal to n, so I know that I want the number of states equal to the length of the string equal to n. I know that for length equals to 0, I need 1 state. For length equals to 1, I need another 1 state. For length equals to 2, I need another state. For length equals to n, I will require n plus 1 states, right? So for example, if I am starting making the DFA, when the length is, so one state will represent length 0, another state will represent length 1, and so on. If I go up to n, I will require how many states? N plus 1 states, because 0 is also there. And then I require one more state to represent strings of length n plus 1. That is basically the dead state. So this is greater than equals to n plus 1. So overall I will require n plus 2 states. So I can also think logically like this, or I can take an example and then based on that I can generalize the things. And this is a straightforward gate question. It was directly asked in one of the gate exams, the generalization for at most n. In one of the gate exams, this was directly asked that how many states will be there in this DFA, right? Is it okay? So similarly, you can generalize for other things also, but what is interesting is at least n. In at least n, we do not require another state called dead state. Why? Why we do not require a dead state here? Why? Because it is greater than equal to n. So even if it is greater, I will still accept it, right? If it is equal and then if it is greater also, I am accepting it. I will not require this dead state in the case of at least n. I will have a self loop over the n plus 1th state on a comma b, because that is also going to be accepted, right? Are you getting my point? So in this case, you will have n plus 1 states, and otherwise you will have n plus 2 states. And for example, for at most n, again the only change will be if I go by the equal to n answer, and if I try to change it to at most n, then all the states earlier which we have drawn, all the n plus 1 states that we have drawn earlier will become your final states also. The last state, that is the n plus 2th state, will not be final state. That will be a dead state, right? So if you go back and try to check, this calculation will be set on all the examples that we have done, and otherwise you can take one example and then put up these answers, or you can come up with the logic and then check back on the examples also, right? Is it making sense? Is it fine till this point? Yes or no? Is it okay? So, yeah, tell me guys, is it okay, fine or not? Great. Okay. So let's move to the next one. So these DFAs we have drawn. Let's see some other kind of DFAs that we can have. Now I change the question to, instead of length as greater than or equal to 3, I want that the number of A's in the string is greater than or equal to 3. So it can also be written as L contains words such that W belongs to A comma B star and number of A's in W. So this is the notation which can be used. Number of A's in W should be greater than or equal to 3. So what does this mean? L contains those words. These words are belonging to A comma B star and number of A's in those words is greater than or equal to 3. So this is how we have changed the question a bit. Right? Can you tell me how many states and how many final states you will require in this case? How many states and how many final states you will require in this case? Let me set the timer for 1 minute. Okay, let me go back. Yeah. Yes, answers guys, time is up. How many states we will have and how many final states we will have? Now we have changed the question to number of A's in the string is greater than or equal to 3 instead of length of the string is greater than or equals to 3. Yeah. What should be the answer in this case? Okay, so let me draw. Now I want the string, the number of A's in the string is greater than or equal to 3. So that means the smallest string which is accepted is basically AAA, triple A is basically accepted. So let me draw triple A. Triple A is accepted. Triple A is accepted. Right? Now, what I am saying is it is greater than or equal to 3. If it is greater also, I am okay. If I am getting more A's also I am okay. Right? Now let me complete the DFA. I have drawn the DFA for the smallest string in the language. Let me complete the DFA. If I am getting B also I am okay. If I am getting now again there is a challenge here, small challenge. Now if I get a B, on this state, my number of A's are not increasing. So I will still remain on this state. If I get a B here, I will still remain here. If I get a B here, I will still remain on the same state. Now what are these states representing? Now again, before we go further, is this DFA correct? Yes. So we require some 4 states and we will have one final state in this DFA. If somebody asks me what percentage of states are final, answer will be out of 5, 1. Okay, out of 4, 1 is there. 25% of the states are final. Now let us see what is each state, what does each state represents here. So for example, here it means 0 A's. Here it means 1A. Here it means 2 A's. Here it means greater than or equal to 3 A's. And over here also I can generalize in the same way. If I replace this 3 with a n, if I replace this 3 with an n, I will get how many states? N plus 1 state. For 3 I got 4 states. For n I can say I can get n plus 1 states. Is it okay? Yeah. Now let us try to move to the next one, which says that such that the number of A's in the string is equal to 3. If I say that the number of A's in the string is equal to 3, what will be the calculations now? When I say number of A's in the string is equal to 3. Yes, tell me. When I say number of A's in the string is equal to 3, how many states will be there? So let me give you 1 minute to solve this. What should be the answer in this case? Okay, time is up. So again over here, if you calculate, you will find out that the number of states in this string, when I say number of A's in the string is equal to 3, then again the number of states will be 5. Here we will require a dead state. Here we will require a dead state. Let us try to draw. Now number of A's in the string is equal to 3. What is the smallest string? A. There can be more strings also. Number of A's are equal to 3. This is also acceptable, and so on and so forth. This is again an infinite language. Epsilon is not there, so initial state is not the final state. Now, when you get an A, your length is increased by 1, another A, length is increased by 1, number of A's is increased by 1. Another A, number of A's is increased by 1. So now it is equal to 3. Now we are at the final state. Now A is accepted. Now if it is more, if I get one more A, I am going to a dead state. If I get to one more state, I will go to a dead state on which I will put a loop. Now if I am getting, okay, so I have already got 1, 2, 3, 4 A's. 4 A's is not accepted, therefore I am going to dead state. Whatever I get after that, I don't care. Now if I get a B here, I will still remain here. Why? Because B does not increase the number of A's, right? B does not increase the number of A's, so this is what will be the DFA, right? Number of A's are increasing 0, 1, 2, 3, and this is greater than equals to 3, right? So this is greater than equals to 4. This is equal to 3. This is equal to A. This is 2 equal to 1 equal to 0. This is number of A's. 0 A's, 1 A's, 2 A's, 3 A's greater than equals to 4. That is rejected. So that is again called dead state. Again, with dead state is also written as trap state in certain textbooks. So this is the state from which there is no path to the final state, right? So dead state is also, the terminology wise, dead state is also called as trap state, right? So again, that's just the terminology which is used. There is nothing, no rocket science behind that, right? So this is how we calculate for the strings in which the number of A's in the string is equal to 3, right? Now, now in this case again, as I said, the number of states are going to be 5 and final states is 1. Now if I change the question and I ask you, is less than, number of A's in the string is less than or equal to 3, what to do in this case? When number of A's in the string is less than or equal to 3, what to do in this case? Right? So can you tell me the states as well as final states in this case? I'll set a timer for 1 minute and then I'll answer it. Yeah. Okay, I think 1 minute is over. What should be the answer, guys? The answer should be again 5. Let us see how do we get it. Now what is being said that the number of A's in the string is less than or equal to 3. So that means 0 A's are also allowed. So in this case, epsilon will belong to the language. Now single A is allowed. Single A can be just A, BA, BAB is also single A and so on. Multiple strings can be written. For 2 A's, I can write AA or I can write BAA, I can write BBA and so on and so forth. So this is again an infinite language. So how will I go? I'll start drawing the string. I will start. So again, this is an infinite language. It should be clear. Number of A's in the string is less than or equal to 3. When I say that length of the string is less than or equal to 3, that was a finite language. But when I say number of A's in the string is less than or equal to 3, then this is an infinite language. Why? Why? Because number of A's, there is a control on the number of A's. There can be any number of B's, so which will again make it infinite, right? So there was so earlier when I gave the question, it was the length of the string is less than or equal to 3. Now what is being said is number of A's in the string is less than or equal to 3. So when I am saying number of A's is less than or equal to 3, what I am trying, again the language is still infinite. When the length was this, the language was finite. In that case the length, so again, yeah, you are correct, your answer is correct, but what I am trying to highlight is one important point. When I was saying the length of the string is less than or equal to 3, when this was the question, the language was a finite language. But when I changed my question to number of A's in the string is less than or equal to 3, then the language is basically an infinite language. Yes. Why? Because the number of B's can be anything, right? So how do we draw this? Again, the number of states will be finite. So let me take this. So let's say this is, so number of A's is less than or equal to 3, so 0 A's are accepted, 1 A is accepted, 2 A's are also okay, 3 A's are also okay, 4 A's, 0, 1, 2, 3, 4 A's are not okay, and after that whatever you get is going to be a dead state, right? And this is basically, if you are keeping on getting B's, then you are not increasing A's, so you are not going to change the state. So basically this is 0 A's, 1 A, 2 A, 3 A, and this is greater than equals to 4 A's. Again, this is the dead state or a trap state. Exactly. Right? So now we have 5 states, and out of which 4 are final. So we have 5 states, out of which 4 states are final states, right? So these are some 7 DFAs which we drew in today's session. We will continue with the same. Let me give you 3 questions in homework which we will discuss in the next session, which is going to be held tomorrow at the same time at 4 p.m. So that is 24th of May at 4 p.m. we'll meet again. Yeah, thanks Ravi. So tomorrow at 4 p.m. we'll meet again to discuss some more DFAs, and we'll have a better practice so that any question which comes in the GATE exam we are able to attempt it properly, and we get the full marks in that question, right? So basically if you see, this is the homework for you. Now one homework is construct a minimal DFA for the given language, and the language is given as L, W belongs to A comma B star, and mod of W mod 2 is 0. What does this mean? What does this term mean? When I say that mod of W mod 2 is 0, what does it mean? It simply means that length of W is even, right? So how do I say that? So this is saying as L is equals to W. It means it contains words or the strings. Strings are basically belonging to A comma B star. Strings will belong to sigma star, and the length of the W mod 2. So this is basically the length symbol. So the length of W mod 2. What is mod 2? So when you are dividing the length with 2, you are getting the remainder as 2. Right? So that we are getting the remainder as 0. When you are dividing the length with 2, you are getting the remainder as 0. That means the length is even. So this is as good as saying that the length of the W is even, right? Try to make the DFA for this. Tell me the number of states as well as the final states. We'll discuss this in the next class. Then the next question is, when the length of the string is odd. That is the second question. And then here I have changed it to mod of W mod 3 is 1. What does this mean? Length of the string when divided by 3, length of the string when divided by 3 gives a remainder of 1. That's it, right? So these are the 3 questions for homework. You have to tell me the number of states as well as you have to tell me the number of final states in all these DFAs, right? I hope the homework is clear, and in the next session we will first discuss these 3 questions and then we will continue further. So just to recall, what is our next session? When is our next session scheduled? On 23rd of May, we have completed this session. We have already completed this session and this session. So on Wednesday, 24th of May, we'll have a session on Deterministic Finite State Automata 2, and then this session is scheduled from 4 p.m. to 5:30 p.m. right? And after that you have, so right now today itself, I think this is not visible. I should change the color. 4 to 5:30 p.m. right? And now today also you have another session at 6 p.m. which will be taken by Ravi sir on computer architecture and organization. He'll be discussing the topic of pipelining. So those who are interested and to understand that concept in a better way should definitely attend that session, right? So I'll see you guys in the next session on 24th of May, that is tomorrow at 4 p.m. Yeah. See you guys.